Hey, what's going on, guys? This is The Blind Side. How you doing today? And as usual, I should let you know I'm completely blind. So if you can't see me in the photo, or you can just see my nose or one of my eyes, if I actually move it back there, I think you should get a pretty good representation of what I look like. You're probably wishing I hadn't moved it now. So this is episode 1 of the What Is series, and the first 10 videos in this series are going to be looking at really weird, strange things in one of my favourite subjects, which is the universe. I'm a huge fan of astronomy, and it's interesting looking at that being blind. I'm assuming my take on things is going to be very different to yours, because you've got all the CGI and all these fancy effects that can computer generate images and graphics that will show things. And today's question is, what is a black hole? Now, I'm sure that most of you know, but a black hole is a result of a massive star that comes to the end of its life. And fortunately, this is not going to happen to our sun. But we'll talk about that in another video. What is going to happen to our sun when it eventually dies? But let's think about stars that are much bigger than our sun, and there are loads of them around. You've probably heard of stars like Eta Carinae, Betelgeuse. These are huge stars. Now, Betelgeuse, apparently, if you look in the sky at the constellations, something that I've never seen, but apparently a constellation is sort of, if you take a group of stars, you can kind of make a shape or a picture out of them. The constellation Orion is quite a famous one, and there's part of that constellation called Orion's Belt, which is made up of 3 really big stars apparently, and one of them, the one on the end, which would look red, is Betelgeuse. Now, it's far away from us, many light years away. But what will happen with Betelgeuse, because it's so big, when it actually comes to the end of its life, is that we'll have a supernova and then a black hole. At least this is what they think. So today's video is going to talk about what all that means. So, a star, as we know from the sun, I mean, we see that every day, is just a massive ball of plasma and gas that produces a lot of energy, which we see and feel, or you see and feel, I just feel, in heat and light, okay? So the sun, stars are actually white in colour, but it's our atmosphere and the way our eyes produce the image for our brains to interpret that makes it have that yellowy colour, apparently. But there we go, that's just a little fun fact there. So what's happening is, nuclear fusion is taking place in the very centre of every star. So a star is born, you've got loads of dust and matter and just rubbish basically in what's called a nebula, okay? And a nebula is, well, you can see them through telescopes. There was a time actually when people thought nebulas were galaxies or whatever, but it's just basically massive areas of dust and rubbish that's floating around in space, and gravity pulls these dust particles and all that kind of thing together, to the point where you've got a ball of stuff that's so massive that nuclear fusion starts occurring in the core. The gravity is pulling everything so close together, and it's so heavy that nuclear fusion's occurring. And that then is the birth of the star. So, as the star goes on through its life, and these stars live for many billions of years, there's loads of different types of stars. The most common star is a red dwarf, and they can live for trillions of years. Our sun is a yellow dwarf. That's got a life cycle of probably around about 10 billion years, so we're sort of halfway through that at the moment. But it seems that the bigger the star, the shorter the expected life. So let's say, for argument's sake, that you've got a massive star and it's got a life expectancy of about 1 billion years. Okay, so the first sort of 3/4 of that you're going to have the star getting brighter and brighter, more nuclear fusion taking place. I mean, we're talking trillions of tons a second of matter fusing together here. That's how big these stars are. I mean, our sun, which is quite a small star really, in astronomical terms, you could fit. Jupiter's 1,000 times bigger than Earth, and you can put 1,000 Jupiters inside the sun. So that sort of gives you a rough idea. I mean, 1,000,000 Earths worth. Unbelievable. Very hard to comprehend. I mean, I'm talking about stars that are millions of times bigger than even the sun. So it's coming to the end of its life, and what happens is it's running out of the basic elements. So the most basic element is obviously hydrogen, and then it goes helium, and so on. Anyone that knows the periodic table, we're talking about the gas elements here. Obviously, the heavier the compound, it'll then go into metals and all that kind of thing. So when it's run out of hydrogen, it continues to fuse from helium, and it goes down the periodic table until it gets to carbon. When it gets to carbon, it basically can't support its own weight anymore. So what happens is the core of the star collapses in on itself. In a split second, this all happens. So you've got all this energy and all this mass falling in on itself, and that causes a huge explosion called a supernova. Supernova is brighter than an entire galaxy. I mean, there's loads of different estimates as to how many stars are in our Milky Way. I've seen estimates up to, 1 trillion, but it's billions of stars, and the supernova is brighter than that. And what happens is you've got the core of the star, which is compressed down into nothing, a singularity, and all the rest of the, plasma and everything that was on the outside is blasted out into space, along with all the heavier chemicals like your gold and your diamond, and your platinum and all that kind of thing. That's why they're so rare, you see, because it's a supernova explosion that produces those elements. So what's left, what was the core, is a black hole. Now, when you're looking at images of black holes, I imagine they look quite flat. It's actually a sphere. Stars, planets, all that, they're all spherical, because obviously space is, it's not three-dimensional, but nevertheless. So you've got a sphere of nothing, and what they think is that at the very centre of that sphere is a tiny, what they call a singularity, where all the matter that was in that star is then in the black hole, in the singularity. Now, this black hole, you've got the singularity and then the event horizon. The event horizon is sort of the edge of the black hole. It's the edge of no return. Basically, they reckon if you cross that event horizon, you cannot escape the gravitational pull of the black hole. All right? So this black hole then wanders around the galaxy, eating up stars, planets, whatever it comes into contact with. There's no stronger gravitational force, so it'll just eat it. I mean, there are different types of black holes. At the centre of most galaxies, if not all, there are supermassive black holes, which are billions of times the mass of the sun. And they are so strong, in fact, that if you think about the Milky Way galaxy, with all the stars and all the planets and exoplanets and everything, and us, we're all sort of rotating around the centre. Well, we are in the gravitational pull of the supermassive black hole, which is, tens of light years away from us. It's crazy, really, that something can have that much gravity. But there you go. So that's what a black hole is. If you've got any questions, leave them in the comments. I try and give you things in a simple way. I don't get scientific on you. That's not what this channel's about. But stay tuned for the next What Is video. Next time, we're going to be looking at very, very strange stars. Until then, I'll see you soon.